What mass of ice do you have if it takes 12 newtons of force to slide it at a constant speed? So we're talking about a kinetic coefficient here, right? And I assume across ice. Add that to your question. Across ice. You really deserve a better teacher. I assume it's ice on ice. Okay. So we're going to use this. So our mu is 0.03, right? We don't have ice on concrete. It's just ice, right? Okay. So our force of friction is going to be mu times r, which is mu times mg, right? And so we can fill this in. It's 12 newtons is our force of friction, right? And the reason, by the way, that a constant speed is relevant is that if it's accelerating, we're actually exerting a force bigger than the force of friction. But if it's moving at a constant speed, then in the horizontal direction, right, we know that the forces are adding to zero. I'm exerting a force that way, but friction is exerting a force that way. If my force that I apply is less than the friction force, it slows down. If the force I apply is more than the friction force, then it'll speed up, right? But if it's a constant speed, these guys are equal. All right, so 12 is mu, so 0.03 times the mass, which we don't know, times 9.81. Okay, so 12 divided by 0.03 divided by 9.81. 40.77, so the mass is 40.77 kilograms. Keeping in mind that we only have one sig fig, we'd have to say about 40. By the way, on my worksheets, my sig figs are very precise.